we're going to continue our work with exponents, and we're going to do lesson 6, which is scientific notation. Okay, and I know that you guys have had scientific notation before, so this lesson is just going to kind of be a review on how to put numbers into scientific notation and then how to take them out of scientific notation. Okay, so let's take a look at your opener here. A single-sided, single-layer DVD has a storage capacity of 4.7 gigabytes. 1 gigabyte is equal to 10 to the 9th bytes. Okay, number 1, write a multiplication expression that represents how many bytes can be stored on the DVD. So I left this answer open. Basically what they're wanting you to do is to write your answer in scientific notation. Okay, we need to take 4.7 gigabytes and multiply it by 10 to the 9th. So this is actually written right here. This is how we write scientific notation. It's always a decimal times some power of 10. Okay? All right, so we want to complete the table below. If we take 4.7 times 10 to the first, okay, what we can do is we can take 10 to the first out of exponential form and just write 10. So 4.7 times 10 is 47. Okay. Then if we take 4.7 times 10 to the second, if we take 10 to the second out of exponential form, we have 100. So 4.7 times 100 is 470. 4.7 times 10 cubed, well, if we take 10 cubed out of exponential form, exponent is 3, so we have 3 zeros. So 4.7 times 10 times 1,000, 4,700. And if we take 10 to the 4th out of exponential form, we've got 4 zeros on there because the exponent's 4. And we take 4.7 times 10,000, we have 47,000. You should see a pattern. Okay. Now if we go the other way, if we have 10 to the first, we learned that 10 to the first is the same thing as 1 over 10. So if we take 4.7 times 1 over 10, we get 0.47. Then we get 0.047 if we multiply by 1 over 100. If we multiply by 1 over 1,000, 0.0047. And again, you should see a pattern here. Okay. So the first question asks us, if 4.7 is multiplied by a positive power of 10, so this side, what relationship exists between the decimal point's new position and the exponent? Well, look, we started at 4.7 and we multiplied by 10. So the decimal went to the back. Okay, the decimal point is actually right here. Okay? If we took 4.7 and multiplied it by 100, the decimal point's here. We moved it 2 places. Multiplied by 1,000, exponent is 3. We moved it 1, 2, 3 places. Okay? Exponent of 4. Okay, we moved it 1, 2, 3, 4 places. Okay? Now, so our relationship then is the decimal point is moved to the right by the same amount of zeros, or by your exponent. We moved it once here, we moved it twice to the right here, 3 times to the right, 4 times to the right. Okay. Now the next question is, well, what's the relationship when we have a negative exponent? It's the same as over here, except we're now moving it to the left. Okay? The decimal point was here, we're going to move it 1 space to the left. Exponent of negative 2, we're going to move it 2 places to the left. 1, 2. Exponent is negative 3, we're going to move it 3 places to the left. 1, 2, 3. Exponent is negative 4, 4 places to the left. 1, 2, 3, 4. Okay? Again, this just should be review for you guys. So your relationship is the decimal is moved to the left by the same amount of zeros. Okay. All right, so let's check out scientific notation here. Scientific notation is when a number is written as the product of a factor and an integer power of 10. The factor must be greater than or equal to 1 and less than 10. Now that's important. okay? And we'll talk about this as we go along. But this factor right here has to be between 1 and less than 10, okay? Let's look at an example here. Write each number in standard form. Now, standard form is just the regular form of a number, okay? So we want to take it out of scientific notation and put it in standard form. Our exponent here is a 4. So we're going to move this decimal point to the right 4 places. So it was right here. We're going to move it 4 places. 1, 2, 3, 4. And there's our new number, 53,400. Okay, our decimal point, or our exponent here is -3. Now since it's negative, we're going to move it to the left 3. So our decimal point was here. We're going to move it 3 places. 1, 2, 3. And there's our new place for the decimal point. Okay. Now notice, look at this number right here. And look at this number right here. These are your factors. And notice it's between 1 and 10. You can't have an 11 point something or a 12 point something. You have to have a single digit. That's part of scientific notation. Single digit. Okay. So right now I want you to use these as an example, and I want you to pause the video and try your got it problems. Alright, let's see how you did. We want to take 7.42 times 10 to the 5th. Now, since your exponent is 5, that means we're going to move to our decimal point to the right 5 places. Okay. So our decimal point was right here. We're going to move it 5 places. 1, 2, 3, 4, 5. So our new answer is 742,000. Okay, on this one, we have a negative exponent, so we got to move it to the left 2 places. So it was right here. Move it left 2 places. 1, 2. So there's our final answer, 0.061. And notice that I have a 0 in there. Okay. Positive exponent of 2, positive, we need to move to the right. So we're going to move it 2 places, 1, 2. So our final answer is 371.4. Okay? Now let's look at putting numbers in scientific notation. Okay, they're going to give us a standard form. They want us to put it in scientific notation. So here's our number. We want that decimal point to go right here, okay, because that's a single digit. So how many places do we have to move it over? 1, 2, 3, 4, 5, 6 places. So notice in our answer then, our exponent is 6. We moved it 6 places. Now let's go the other way. This is a very small number, okay? Our decimal point has to go right in here because that's a single digit right there with that 3. So we have to move it 1, 2, 3, 4 places, but we moved it 4 back. So that's why we have a negative exponent of 4. Okay, -4 for your exponent. Use those 2 examples and try D, E, and F. Go ahead and pause the video. Alright, let's put these numbers in scientific notation. Okay. Our decimal point has to go right here, okay, so that we have a single digit here. So how many places do we have to move it? 1, 2, 3, 4, 5, 6, 7. So we should have our final answer being 1.414 times 10 to the 7th. Okay, and notice I don't stick those zeros on the end over here. They're not important, okay? Alright, here our decimal point has to go right after the 8 so that we have a single digit. So how many places do we have to move it? 1, 2, 3. But we had to move it back the other way. It's a very small number, so we're going to have a negative exponent. We moved it 3 places, but we moved it to the right, so we have to move it a -3 spaces. Okay, in this problem, our decimal point has to go right here. So we're only moving it 1 place, but we had to move it back 1. So our exponent is going to be a -1 here. 1.14 times 10 to the -1st. Okay? Alright. The last thing they're going to do is they're going to have you compare numbers in scientific notation. Very easy to do. they want you to put the countries in terms of dollars spent from greatest to least, so the biggest one first. Look at your exponents. The numbers with the bigger exponents are going to be bigger numbers. So let's compare the United Kingdom first to Canada. Okay, they both have an exponent of 7. So now let's compare 1.03 and 1.06. Well, 1.06 is bigger, so the UK is going to be first, then Canada. Then let's compare these two because they both have exponents of 6. Well, 7.15 is bigger than 1.83. So it should be United Kingdom, then Canada, then Mexico, then India. Okay? Why don't you take a look at these two these 4 cities, and they want you to order the cities according to the number of visitors from least to greatest. So we're looking for the smallest number first. Okay, go ahead and pause the video and see if you can put these numbers from smallest to largest. Okay, so if we're looking for our smallest cities, we're going to look at our exponents with 5s, okay, because they're smaller exponents. So now all we have to do is compare 7.21 and 9.01. Well, Boston has the that's 7.21 is smaller. So Boston's going to be our first city. Okay. And then the other exponent of 5 is DC. Okay. Now let's compare exponents with that are 6. We need to compare 1.3 and 2.2. Okay, well 1.3 is smaller, so Las Vegas would be next, and our biggest city would be Los Angeles. Okay? Okay, last problem here. If you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8th seconds to walk to the moon. Is it more appropriate to report this time as 1.92 times 10 to the 8th seconds or 6.09 years? Explain your reasoning. Well, when you're looking at this, it's going to be easier if you say 6.09 years because we understand how much time that is, 6 years. We understand what 6 years is. If we use 1.92 times 10 to the 8th seconds, that's so large that we don't understand how big it actually is. So using a larger measurement here is actually going to be easier. In your got it problem, okay, it says in the ocean the sea floor moved 475 kilometers over 65 million years. Is it more appropriate to report this rate as 7.31 times 10 to the negative 5th kilometers per year or 7.31 centimeters per year? Explain your reasoning. Well, which one do you understand better? Do you understand 7.31 centimeters per year? Or is it easier if you say 7.31 times 10 to the negative 5th kilometers per year? Well, obviously, it's going to be easier if you say 7.31 centimeters per year because we know physically how much 7 centimeters is, and we understand that a little bit better. So sometimes it's a little easier to use the larger unit than it would be to use scientific notation. So what I want you to do right now is go ahead and try your guided practice, and we will go over that first thing in the morning. Okay.